In this video, we're going to look at how to create crowds that walk around. We'll use the mass entity system. If you have no experience with it, no worries. We're going to work through it from scratch. Now, I should say this video follows the instructions Unreal provided in a post called Your First 60 Minutes with Mass. A link to it's in the video description. So let's start by creating a new project. I'm going to name it Mass Entity. Mass Entity requires we enable some plugins. So let's go to Edit, Plugins, and enable Mass Gameplay, Mass AI, Mass Crowd, Zone Graph, and State Tree. Unreal is going to make us restart to enable the plugins. Now that we are back, let's create a new basic level by going to File, New Level. Now the first step is to create a mass entity config. Open the content drawer, right-click, go to Miscellaneous, Data Asset, and then Mass Entity Config Asset. Let's rename it to Mass Entity Config Person. Let's open it up, and it's pretty empty. Open Config, and we're going to add a trait with the plus button. Let's add Debug Visualization. And if we expand the trait's debug shape, we can set the mesh we will use for visualization. Let's set it to cone, and update the col distances to 0 and 25,000. So now we have described a super simple mass entity. Let's spawn our mass entity in the level. Press the Add button in the viewport, search for mass spawner, and drag a mass spawner into the level. In the Details panel of the spawner, expand the spawn section. Let's set the count to 25, which is how many entities we want to spawn, and add an entry to the entity's type. And let's set its entity config to the entity config we just created. Now we also need to set the spawner's spawn data generator. The spawner needs to know where to spawn the entities. So set the generator instance to EQS spawn points generator. This is saying we're going to use an environmental query to determine where to spawn the entities. So if we expand the query, EQS request section, we can see where we set the environmental query to use. Let's create a new query. Let's name it EQS spawn entities in donut. You can also right-click in the Asset Browser, Artificial Intelligence, Environmental Query. Let's open Spawn Entities in Donut, pull off the root node, and we will use a built-in generator, Points Donut. Set the inner radius to 1000, outer radius to 3000, number of rings to 5, and points per ring to 12. So this is going to get the points in the level that our entity spawner will use to spawn our entities. Make sure the query template on our mass spawner is set to EQS spawn entities donut. If we hit play, we get cones spawning. Pretty exciting, but let's make our cones movable. In our entity config, change debug visualization to mass movable visualization. This supports LOD levels. So there's an LOD level for static mesh representation, high-res actor, and low-res actor. Which one of these the entity displays depends on the LOD settings. So we can use more low-res actors when the entity is far away. Let's set the mesh to cone, and we're going to want to use the BP third-person character for the low and high-res actors. I created a first-person project, so I need to go and download the third-person content pack. To do that, go to Add Content Pack Third Person. Then let's grab the BP third-person character, duplicate it, and name it BP Mass NPC. Then go back to the Mass Entity config and set the low and high-res actor to BP Mass NPC. Now validate entity config and it should complain. This is expected. Some traits depend on other traits and fragments to also exist on the entity. Anyway, the validation shows errors for missing traits required for mass movable visualization. You can click the recommended fix in the output window, Add Mass LOD Collector Trait. Then if we validate again, we see another error that the mass actor fragment is missing, and we can add it using the assorted fragments trait. So let's add the assorted fragments trait. And then we can add the mass actor fragment. It is also complaining about the transform fragment, so we'll add that as well. Now if we validate again, no errors. There is one other change we need to do, which isn't readily apparent, but we need to enable some processors to auto-register with their entities. There is no way you would have known to do this. Go to the project settings, engine, mass, module settings, mass entity, and processor CDOs. We need to find that mass LOD collector processor, mass visualization processor, and mass visualization LOD processor. You can enter them into the search bar, otherwise it's really hard to find them in this list. And then on each one, enable the auto register with processor phases flag. Now with those enabled, let's preview our scene, and if we zoom in and out, the entities swap between the cone and our actor. The people are halfway through the floor, because the origin of the actor is at the center of its collision capsule. This is no big deal. We can do a Z offset in our environmental query. So let's open up EQS spawn entities in Donut, select the Donut node, and in projection data, set trace mode to geometry by channel, and set the trace channel to visibility. And then set post projection vertical offset to 90. 90 is half the height of the BP third person actor's collision capsule. Bada bing, bada boom. Now they're spawned on the ground. Let's create a low-res actor now. Open Content Drawer, right-click, Create Blueprint, Actor Type, and name it BP Low-Res Mass NPC. Add a skeletal mesh and assign it the SKM Mani Simple. We'll offset it down -90 on the z-axis to match our other BP actor's offset. Set animation to use animation class ABP unarmed. And now open mass entity config, and under the mass movable visualization trait, set low-res actor to BP mass low-res actor. Under LOD params, we can set the count of each actor type. This is really useful for making sure we don't spawn too many high-res actors that eat up resources. Under LOD params, LOD max count, set a total of 5 for high LOD max count and 10 for low res. Now if we play, we see the closest 5 entities are a female actor, and the further away actors are the low-res actor. Some faraway actors show the cone mesh and low-res actor. We can fix that later. Let's continue working towards movement. So for movement, there are 2 main ways, using a zone graph or a nav mesh. Let's start with the zone graph. Zone graphs are pathways with directional lanes, like roads. Let's click the Add button and drag in a zone shape. We need to turn on zone shape visibility by going to the View tab and searching for zone graph. Now we're going to assign a lane profile to our zone shape. You define lane profiles in the project settings. So go to Project Settings, Zone Graph, add a lane profile. Let's name it Feels Cool Lane. Add a forward and backward lane and set its tags to default. Now if we select the zone shape, we can assign Feels Cool Lane to its lane profile, and now you can see our forward lane and back lane. We'll create some more points and move the zone shape to be a rough loop. Select each point and change its type from sharp to Bezier to get more gradual turns. Nice. Now a fun quirk with zone graphs is that they cannot loop to themselves. We will have to create another zone shape that connects our starting and ending points. We will give it the Feels Cool Lane profile. You'll notice at the ends of the lanes, there are little gray chevrons. If you move the end of the new zone shape chevron over to the other lane chevron, they will glow white. That means that the zone shape ends are connected. Let's do that to the other end. And there you go, they're connected. Now we need to tell our spawner to spawn our entities on the zone graph. So on the detail panel of our mass spawner, go to Mass, Spawn, Spawn Data Generators, and change the generator instance to Zone Graph Spawn Points Generator. On Generator, Zone Graph Generator Config, set the tag filter for any tags to default. Now if we hit play, you will notice that nothing is spawning. Well, that is because we created the zone shapes, but we didn't actually create the zone graphs. We have to build zone graphs from zone shapes. We can do that manually by going to Build Zone Graph. Now if we hit play, they spawn, but it's annoying to have to remember to manually rebuild the zone graphs. So let's rebuild them automatically by going to Project Settings, Engine, Zone Graph, Build Zone Graph while editing, and set it to True. So now let's open up our entity config and add the traits movement, steering, smooth orientation, and avoidance. On the movement trait, set the movement style to default. Avoidance requires the agent radius fragment added, so add that to the assorted fragments trait. Then add zone graph navigation and navigation obstacle traits. On zone graph navigation, set the lane filter any tag to default and set the query radius to 5,000 centimeters. Then let's add a state tree trait. Open it up and let's create a new state tree of type mass behavior schema. Let's open it up and add a state called wander and a state called idle. On wander state, add task ZG find wander target. Set allowed annotation tags to use default for any tags. Add another task ZG path follow. Set its target location to ZG find wander results. Set movement style to default. Add a transition set trigger to onState completed and set it to transition to idle. On the idle state, add a ZG stand task. Set its duration to 1.5 and add a transition to state that goes to wander on complete. Now if we go and play, the cones are moving, but not the BP actors. This is because the BP actors need to have a mass agent component added to it. So let's open the BP mass MPC and low-res mass MPC and add a mass agent component. We need to sync between mass and actor. Syncing will be done by assigning another entity config to the actor's mass agent component. So let's create a new mass entity config. And name it mass entity config puppet. Add the agent movement sync trait and set the sync direction mass to actor. And add agent feet location sync and set sync to be actor to mass. Then let's go to our BP mass MPC and BP low-res mass MPC, and on the mass agent component, on entity config, assign it to mass entity config puppet. So if we run now, we can see our BP mass NPC moving, but not our low-res NPC moving. This is because the agent movement sync expects a character movement component, which doesn't exist on our low-res actor. That's fine. For now, update our entity config to use BP mass NPC for both low and high res. And now they're all moving around. I know it's lazy, but for this example, let's set the animation to use MF pistol walk forward. Nice. Now let's make our entities aware of the player so that they navigate around them. To do that, let's create another mass entity config. We'll call it mass entity config player. Open it and add the traits navigation obstacle, agent capsule collision sync, and set the sync direction to actor to mass. Now we have to add a mass agent to our character. I'm using first person character, so I'm going to open up BP first person and add a mass agent component. Set the entity config to the one we just created. Now if we hit play, the characters path around us. Next, let's quickly update our entities to use a nav mesh. So let's add a nav mesh bounds volume to the level. And under visibility, set it to show navigation. You can see the navigable area highlighted green. Let's scale the mesh bounds volume along X and Y by 50 and Z by 5. Now everything is navigable. Then, let's duplicate our mass entity person config and rename the duplicate config to mass entity config person nav mesh. Then let's open it up, and under traits, let's change zone graph navigation to nav mesh navigation. Now we need to add a new state tree. So let's duplicate the old state tree and rename the duplicate to ST nav mesh navigation. Open it up, and on wander, change ZG find point to nav mesh find random reachable point. And path follow to nav mesh path follow. Update the target location to use the nav mesh find random reachable point. And set movement style to default. Then for idle, change wander ZG stand to nav mesh stand. And set the duration to 1.5. Let's also go back to the nav mesh, find reachable point, and bump up the search radius. Okay, so let's go back to our entity config and change it to use the new state tree. And there you go, they are moving. Sub if you think this content is helpful. Thanks, bye.